name of our handler. I also added a respective EF core configuration class, and I'm setting the table name to be Outbox message consumers. The primary key, and this is important, has to be the Outbox message ID as well as the name. So I'm actually defining a composite key in my database, and now I need to apply this type to all of my database contexts and create another migration that's going to add this table to the database. As we have already done this for the Outbox messages table in the previous lesson, I'm going to do this behind the scenes, and then we can continue with our implementation. From this point, our implementation is nearly complete. I'm going to add one more file to the user's infrastructure project inside of the Outbox folder. And this is my idempotent domain event handler. Of course, you can grab this class from under this video, and then let me walk you through what is happening here. So this is a generic implementation of the domain event handler class, and notice that we are injecting an instance of an iDomain event handler as a decorated type, as well as a database connection factory. Inside of the handle method, we have a few simple steps. First, we create our database connection, and then we are going to do an eager check if we have already consumed a message with the identifier of this domain event. Remember that the domain event identifier is also the identifier of the Outbox message. If it turns out that we have consumed this message, then we're just going to return from our idempotent domain event handler. Otherwise, we are going to call the handle method of the decorated domain event handler, and after this completes, we can insert a new record into the Outbox consumers table and specify that we have successfully consumed this domain event ID, which also means that we have consumed a specific Outbox message. Now, if you take a look at the implementations of this method, we have a select exists query from the Outbox messages consumer of the user schema, and we are passing in the respective Outbox message ID and the name of our handler. In the insert Outbox consumer method, we are inserting to the same table, and we are passing in the Outbox message ID and again the name of our handler. And notice that the handler name is actually the name of the decorated domain event handler, which would be something like user registered domain event handler, user profile updated domain event handler, and so on. One more thing remaining is how to register this decorator with dependency injection, and I'm going to introduce a library in the common infrastructure project. So let me go ahead and add another NuGet package, and I'm going to look for the one that I mentioned at the start of this video, which is Scrooter. So let's go ahead and install Scrooter, and then I will head to the users module where we introduce the idempotent domain event handler, and I'm going to update the method for registering my domain event handlers. And this is the piece of code that is missing, which you can also grab from under this video. And what we are doing here, after we have registered the domain event handler implementation as a scoped service, is also extracting what is the concrete domain event that this domain event handler is handling. I know this is a bit confusing, but what we are doing is getting the interfaces of this type, looking for a generic one, and taking the generic arguments of that interface. Because this is the iDomain event handler interface, we will only have one argument, which is our actual domain event. Then I can create a concrete type of my idempotent domain event handler using the domain event, and then we have this call here to services decorate, which is going to decorate my domain event handler implementation using the idempotent domain event handler that we created in the previous step. And this is a method from Scrooter that allows us to implement service decoration using dependency injection. I'm also going to add this code snippet to the other module classes in my system, which also means I will need to introduce the respective idempotent domain event handler implementation for each of those modules. What's going to be different in those implementations is just specifying the correct schema for the given module, and there are a few reasons why we have to do this. First of all, because we are using assembly scanning for a specific module to resolve a handler for a given domain event. Remember that we are also doing the same in our domain events handler factory. If you recall our discussion about the limitations of the dependency injection system in ASP.NET Core, this is our way of going around this by making sure that we are only working with the types from a given module. And unfortunately, the price we have to pay for this is a little bit of code duplication between our modules. Now I'm going to place a few strategic breakpoints inside of our solution and start the application and show you how all of this works. So the first breakpoint that I placed is inside of the add domain event handlers method that's going to get a list of domain event handlers from the given assembly. And these are the user profile updated domain event handler and the user registered domain event handler. Then we're going to register these types with dependency injection and also decorate them with an idempotent domain event handler implementation for each of these domain event handlers. So I'm going to hit continue, and now I'm going to call the update user profile method from Postman, which is going to update the first and last name of the current user, and this is going to raise our respective domain event. So if I hit send, you can see the request completes, and eventually we're going to hit the breakpoint inside of our Outbox processor, which is what happens. And now if I deserialize my domain event and obtain the handlers for this domain event, you can see that I get an instance of the idempotent domain event handler for the user profile updated domain event. And now if I go into the handle method, you can see that we will move into the handle method that's inside of the idempotent domain event handler. And from here, we can check if we have processed this Outbox message. If we did not, we can step into the decorated type, which is the user profile updated domain event handler. So our service decoration is working as expected. And here we just published the user profile updated integration event, which is going to be handled by the other modules in our system. And now we can write that we have successfully processed this Outbox message from a consumer called user profile updated domain event handler. So let's go ahead and write this to the database. And now I can complete my background job. And if I go into the database and show you the Outbox messages table, you can see the user profile updated domain event as an Outbox message. Now, if we check the processed on property, you can see that it was processed, but what happens if I delete this field and now it has a null value and save this? What's going to happen is it will eventually be picked up by the process Outbox job in the users module. So if we try to publish the same domain event again, here's what is going to happen. I'm going to step into the idempotent domain event handler, and this time you will see that the check if we have handled this domain event will succeed, and we are just going to return from the domain event handler, and we will not be invoking our actual domain event handler twice, preventing the duplicate execution for a specific domain event. And this is how we can implement the idempotent consumer pattern for our domain events, or the Outbox messages to be more precise. And the final implementation comes out to be simple. We just have an eager check on the database if we have processed the current Outbox message, processing the message if we did not, and then storing the record of successfully processing that Outbox message in the database. This also allows us to rerun our Outbox messages if we have some handlers that failed for some reason, for example, because of a transient failure or because we had some bug in the system. So we could go ahead and fix any problem that we have and safely process the remaining Outbox messages. And this brings us to the end of the current lesson, where we implemented the idempotent consumers pattern for our Outbox. In the next lesson, we are going to implement the inbox pattern for processing our integration events, as well as the respective idempotent consumer implementation for the integration event handlers.